Hello, Mr. C here, and in this video, I'm going to discuss the product, quotient, and power properties of logarithms. Let's begin. In our first expression, we have log base a, and in its argument, we're multiplying m times n. This is going to yield the product property of logarithms because inside the argument, we have a product. What we're allowed to do is expand this into two log base a's. Let's write log base a. We'll set up parentheses for its argument. Let's scooch over to the right. Let's write log base a with parentheses for its argument as well. There's going to be an operation between these two logs, and that operation is going to be addition. So just by virtue of what I've written down, if we take the log, a single log, of a product, it splits up into the sum of two logs. Now notice that these two logs have a base a, so it's important that when you go to apply this product property, that the two logs you write out have a base that's consistent with the original one. Now what's going to go inside the arguments of each of these, you might be asking? Well, in the first argument is going to be the first factor of this product, which is m. All right, so for the second log's argument, we'll have the second factor, which is n. And that's the product property in its fullest form. So in words, log base a of m times n is equal to the sum of log base a of m and log base a of n. So it's important to just keep in mind that multiplication breaks up into addition. With that said, you can probably guess what's going to happen if the argument of the initial log here is division. All right. Well, if multiplication splits up into addition, then division should break up into subtraction, and that's exactly what happens. So there's going to be two logs again, log base a of blank, log base a of blank for now, and the operation that's going to separate these two logs is subtraction. Now as for the argument in each of these, the order is important. The first log's argument is going to be the numerator of the fraction inside of the initial logarithm, whereas the second log's argument is going to be the denominator, or as Arnold would say, the denominator, then get to the job. So anyway, this is the quotient property in its fullest form, which says basically that division breaks up into subtraction. The last property is known as the power property. And this property is unique in the sense that it's not going to split up into two separate logs. Rather, this is a property that is super useful, especially if we have variables in the power of an exponential expression. For instance, if we have log base a of an expression raised to a power of r, then what we're allowed to do by virtue of this property is bring that power of r down in front of that log. And so this would be rewritten as r times log base a of the argument m. All right, so you'll notice there's no more power on that m because it was brought down in front, and that power becomes a factor. Okay, so just to kind of summarize, by these three properties, multiplication turns into addition, division turns into subtraction, and powers come down as factors. All right, in the next video, we'll go ahead and put either of these three to use.